Hello everyone, so today in this video we are going to discuss the question factorial divisibility, which is asked in Codeforces Round 829 Div.1. In this question we are given an integer x and an array of length n, a1 से an, and we have to determine whether a1 factorial plus a2 factorial so on till an factorial is divisible by x factorial or not. So let's first understand the meaning of factorial. Suppose 4 factorial is 4 into 3 into 2 into 1. Therefore, n factorial is n into n minus 1 into n minus 2 so until into 1. So we are given numbers a1, a2, a3 so until an, and we have to tell whether a1 factorial plus a2 factorial plus a3 factorial so until an factorial modulo x factorial is 0 or not. We have to tell whether this number is actually divisible by x factorial or not. We are also given that all the values of ai are less than equal to x. We are also given that all the values of ai are less than equal to x. All the values of ai are less than equal to x. So let's move on to the approach of this question. Here is an important concept which is behind this question. The concept is, suppose you are given n factorial. We know that we can write n factorial in the form of n into n minus 1 factorial. Or I can say, suppose I am given n factorial. I can write n factorial in the form of n plus 1 factorial divided by n plus 1. These are the two major concepts which we going to use in this question. And another important concept which is used here is, let's try to find out the sum of 1 factorial, 2 into 2 factorial plus 3 into 3 factorial. So and here's an important observation which is behind this statement which I wrote, that is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial. First let's find out the value of this. It is 1 plus 2 factorial is 2, 2 into 2 4, then 3 factorial is 6, 6 into 3 18, 18 1 plus 1 19, 19 plus 4 23. Let's now find out the value of 4 factorial. 4 factorial is actually 24. We can see that the value of this expression and the value of 4 factorial, there is a difference of 2. There is a difference of 1 only. Here the value is 23 and here the value is 24. The difference is of 1. So we can generalize this is like that: 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial so on till n into n factorial is always less than by how much amount? Less than by 1, is always less than n plus 1 factorial. We can generalize this. So we got three important observation. The first important observation is this one, that 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial so until n into n factorial is always less than n plus 1 factorial. And the other two observations are that n factorial can be written as n into n minus 1 factorial, and n factorial can also be written as n plus 1 factorial divided by n plus 1. So with these three observations, we will now move on to the solution part. So in the first step, what we will do is, let's take this example. So in this example, we are given that 3 2 2 2 3 3. So what I will do is, I will first write all the elements from 0 to x. Here we have given x is equal to 4. So 0 1 2 3 4. In this array which we are given in the question, we can see that the 0 is present 0 times, 1 is present 0 times. We can see that the 2 is present 3 times, 2 is present 3 times, and we can also see that the 3 is also present 3 times, and we can see that the 4 is present 0 times. So what we can, this array is also very useful in our question. So what we can say that here, suppose 0 is present 0 times, it means it means we are 0 is, it means answer is 0 here only. If 1 is present 0 times, then also answer is 0. If 2 is present 3 times, what does it mean? Actually in the array we are given 3 times 2. It means that we have to add 2 factorial 3 times, that is 2 factorial plus 2 factorial plus 2 factorial. So 2 is present 3 times means we can write it as 3 into 2 factorial. In the same manner, we are given 3 times 3 is given. 3 times 3 is given, so we can say that 3 times 3 is given. In the array, we are given 3 times. So what does it mean? It means that we have to add 3 factorial plus 3 factorial plus 3 factorial 3 times. We have to add 3 factorial 3 times. Therefore, I can write it as 3 into 3 factorial. We are given 4 0 times, therefore it contributes 0. So from here, what I can say is that 3 is present, 2 factorial is present 3 times plus 3 factorial is present 3 times. I can write it as, if we apply the concept of that, we can write n factorial as n plus 1 factorial divided by n plus 1. So we can write it as 3 factorial plus 3 into 3 factorial, which is actually 4 into 3 factorial, and we know that the 4 into 3 factorial is divisible by Rx, which is 4, which is actually 4 factorial in this case. Why? So because 4 into 3 factorial is also 4 factorial, and modulo 4 factorial gives us 0. So the important point here in this section is this section. The statement I've written here, that 2 factorial is present 3 times and 3 factorial is present 3 times. So I can write 2 factorial which is present 3 times as 3 factorial, and the 3 factorial which is present 3 times I write it as same, and then I combine both of them to get 4 into 3 factorial, and I know that the 4 into 3 factorial is actually 4 factorial, which is divisible by 4 factorial. Therefore answer is yes. Let's move on to another example, and we will analyze all the examples one by one, so that we will be able to get the clarity of how to actually solve the equation and write the code for it. I have not yet told you how to write the code. I am just giving you a brief of what we are actually doing in this question. After analyzing all the test cases, we will be able to see that actually how we have to write the code, and we will be able to see when answer is yes, when answer is no, and how where we will got stuck up in the question, and so on, and other things also. So as I told you further, first we will write all the elements from 0 to x. So we will write 0, 1, 2 and 3. We will see that the 0 is present 0 times, so 0 is present 0 times, 1 is present 2 times, 2 is present 1, 2, 3, 4, 5, 2 is present 5 times, and we can see that the 3 is present only 1 time. So what I will do is, as 0 is present 0 times, so it will contribute 0. As 1 is present 2 times, so 1 is present 2 times means the answer contains 1 factorial plus 1 factorial. So 2 into 1 factorial. 2 is present 5 times, so 5 into 2 factorial. 3 is present 1 time. 3 is present 1 times, so it means 1 into 3 factorial. This is the same which I had done above in the previous example. Now what we will do is, I will try to convert. Let me increase the size of the page. So what I will do is, I will try to convert this 1 factorial into 2 factorial, and then this 2 factorial into 3 factorial. Why I am converting this 1 factorial, I mean to say k times 1 factorial, let's say 1 factorial into 2 factorial. Reason being, if 1 factorial and 2 factorial, if 1 factorial gets converted into 2 factorial, then it is easy for us to combine both of them. And as we get 2 factorial, then after converting that 2 factorial into 3 factorial, it is very much easy for that to get a combination of 3 factorial. So what I will do is 2 times 1 factorial plus 5 times 2 factorial plus 1 times 3 factorial. We can write 2 into 1 factorial as 2 factorial. We can also write 5 into 2 factorial as. So now we will first combine this 2 factorial and 5 into 2 factorial, which we can write it as 6 into 2 factorial. Now we can write 6 into 2 factorial in the terms of 3 factorial as we can do like 6 by 3, and we can multiply 3 into 2 factorial, which is actually 3 factorial. This is actually 3 factorial and this is 2. So 2 into 3 factorial plus 1 into 3 factorial. So we will get let me clear out some space first. So what we can see here is 2 into this 2 into 1 factorial. We can write it as 2 factorial, 5 into 2 factorial, and 2 factorial are combined to get 6 into 2 factorial, and this 6 into 2 factorial can be further written as 6 by 3 into 3 into 2 factorial, and this section we can see it is 3 factorial, and we can see 6 by 2 is 6 by 3 is 2. So what I left with is 2 into 3 factorial plus 1 into 3 factorial, which is actually equivalent to 3 into 3 factorial. And we can see that the 3 into 3 factorial is divisible by Rx factorial, which is actually 3 factorial. So we can say the answer is yes. So let's recap these steps again. So steps are, first we will write all the elements from 0 to x. Then what we will do, we will maintain a frequency count, that 0 is present 0 times, 2 is present 2 is present 5, 2 is present 5 times, 1 is present 0 is present 0 times, 1 is present 2 times, 2 is present 5 times, 3 is present 1 times. Then we will write their meaning. 0 is present 0 times means answer is 0. 1 is present 2 times. 1 is present 2 times means 1 factorial plus 1 factorial. It means 2 into 1 factorial. Similarly 5 into 2 factorial. Similarly 1 into 3 factorial. Then we will try to convert this 2 into 1 factorial into 1 factorial term into 2 factorial term. Then combine both the 2 factorial terms, then try to convert that 2 factorial term into 3 factorial term, and so on till end. We have to do this. We have to do this till x minus 1, not till x. I had done here till x, but we can do this till x minus 1. Reason being, if we will be able to do this, here we can see that the x minus 1 is this, and till x we have this. If I will be able to convert this 2 factorial into 3 factorial, it means the combination of 3 factorial will always be divisible by x factorial, which is of course the last one. So we only have to convert it, that is 2 factorial into 3 factorial till. We will not have to go further, that is we don't have to convert 3 factorial into 4 factorial. So let's analyze the no case answer when the answer would have been no. So let's analyze this case when the answer is no. After that, we will be able to get to all the concept that when the answer should be yes and when the answer should be no. So here we can see we can write the elements from 0 to 5, 0, 1, 2, 3, 4 and 5. We can see that the 0 is present 0 times, 1 is present 1 time, 2 is present 1 and 2 time, 2 is present 2 times, 3 is present 1, 2 and 3, 3 is present 3 times. We can see that the 4 is present 1, 2, 3 and 4. 4 is present 4 times, and the 5 is present. 5 is not present. 5 is present 0 times. So we can say 2, 1, 3, 4, 5, 6, 7, 8, 9, 10. There are total of 10 elements. So what we can do is 0 is present 0 times. It means the answer is 0. 1 is present 1 times. It means 1 into 1 factorial. 2 is present 2 times. It means 2 into 2 factorial. 3 is present 3 times. It means 3 into 3 factorial. 4 is present 4 times, it means 4 into 4 factorial. 5 is present 0 times, it means 0. So what we will do now is, let's try to convert this 1 factorial into 2 factorial, and then those 2 factorial into 3 factorial, then those 3 factorial into 4 factorial, and then those 4 factorial into 5 factorial. So let's try to convert that. We can see that the 1 into 1 factorial, if we want to combine it, if we want to make it into 2 factorial, what we will do is we will multiply by 2 and divide by 2. So multiplication by 2 and division by 2, that is 1 by 2 and 2 into 1 factorial, which is actually 2 factorial. Multiply by 2 led to 2 factorial, but here it is 1 by 2, which is not an integer, so we won't be able to combine this and this, so we can't be able to convert this 1 factorial into 2 factorial terms. Can't be able to express this 1 factorial in the terms of 2 factorial. So our answer contains 1 plus in the previous cases which we had seen, we will be able to see that we will completely be able to combine, or I can say convert 1 factorial into 2 factorial, then that combination of 2 factorial into 3 factorial, then that combination of 3 factorial into 4 factorial, but here we won't be able to convert 1 factorial into 2 factorial. Now let's try to convert this 2 into 2 factorial into 3 factorial. For that we have to divide by 2 and divide by 3 and multiply by 3. We can see that 2 by 3 into 3 factorial, which we further do not combine, so it will only 2 into 2 factorial only. Similarly, we can try to convert 3 into 3 factorial into 4 factorial. We won't be able to convert as 3 by 4 into 4 factorial it would be. So we will see 3 into 3 factorial. Similarly, we can see we won't be able to get 4 into 4 factorial. Won't be able to convert 4 into 4 factorial in the terms of 5 into 5 factorial. So 4 into 4 factorial. So now we have got this term. So what we have to think of, whether this term is divisible by r x factorial or not. In all the previous cases, we had seen that the term, we can convert the previous term into in the terms of another term. Then we will easily be able to combine it. Then we will convert that term into another term, and we will easily be able to combine it, and so on. We will see that at the end it will be easily divisible by x factorial. But here we can see that we won't be able to convert one term into each term. So I will give you the proof right now, but you will remember for a while that if we won't be able to convert any one term into the another term, suppose here I won't be able to convert 1 factorial into 2 factorial, it means the answer is no. You can remember that I am giving you the proof right now. The proof behind it is, let's say after we can see that we can't be able to convert 1 factorial into 2 factorial, so I had written 1a here, 2 into 2 factorial here, 3 into 3 factorial here, 4 into 4 factorial here, so on. What we can see that if we want to convert, suppose I had 5 into 2 factorial written with me, what I can write it as 2 factorial plus 4 into 2 factorial, or in another way I can write it as 2 into 2 factorial plus 3 into 2 factorial. What I can see is that I can convert this 3 into 2 factorial in the terms of 3 factorial. How? 3 into 2 factorial is actually 3 factorial, but this 2 into 2 factorial remains. So if I want to convert y into x factorial, I want to convert into the x plus 1 factorial term. So this y here, this 5 into 2 factorial actually gets converted to 3 factorial, leaving the term 2 into 2 factorial. So I can convert this y into 2 factorial into some term of x plus 1 factorial, into some k terms of x plus 1 factorial, leaving let's say j terms of x factorial. So this k times of x plus 1 factorial gets combined with the further x plus 1 factorial, but this j into x factorial remains same. So what we can say, what is the maximum value of j we can get? We can see that the maximum value of j can be less than y, can be equal to y minus 1. J can only be less than equal to y minus 1, because if j is equal to y, j can be less than equal to I can say j can be less than equal to x minus 1, or I can say j can be less than equal to x. I can say j can be less than equal to x, y. So the reason being, I can't be able to convert 3 into 3 factorial into 4 factorial, but I can convert 4 into 3 factorial into 4 factorial. I can also convert 5 into 3 factorial in the terms of 3 factorial plus 4 4 into 3 factorial, which is actually 3 factorial, which is some terms remaining plus 4 factorial. So I can say j, the maximum value of j can be less than equal to x. The maximum value of j can be x. The maximum value of j can be x. The maximum value of j, this can be x. So what we have, it is also an important observation that if we will be able to convert y into x factorial in the terms of k into x plus 1 factorial, then the remaining section is actually j into x factorial, where the j is actually less than equal to x. So what we can say is, let's say we convert some sections of 1 factorial into 2 factorial and some things are remaining, then we can convert some sections of 2 factorial into some sections of 3 factorial. Let's say k times of 2 factorial, k1 times of 2 factorial. Let's say k1 times of 2 factorial and some sections are remaining. Let's say then we convert k times of 3 factorial into some sections of 4 factorial. Let's say k2 times of 4 factorial and some sections are remaining. Now we can say that the sections which we are be able to convert, that is 2 factorial into 3 factorial, then 3 factorial into 4 factorial, at the end they will easily be able to divisible by x factorial. But the remaining sections which are remaining, will their summation also divisible by x factorial? So what I can say is, if suppose some sections of 1 is remaining, so what is the maximum value that the some sections of 1 will be remaining? It is 1 into 1 factorial. The maximum value of 2 section which can remain, the maximum value of 2 section which can remain, because if it is 3 into 2 factorial, we will easily be able to convert into factorial 2 plus 3, we will easily be able to convert into 0 plus 3 factorial. So what I can say is, a number which is k times factorial 2, where k can be maximum x. In easy words, what I mean to say is, suppose a number of 2 factorial, k times 2 factorial, I tried to convert it into k1 times of 3 factorial and some sections remains. Let's say L times of 2 factorial. What is the maximum value of that L times 2 factorial? Maximum value, that L times 2 factorial maximum value is 2 factorial, 2 into 2 factorial. Why? Here I had proven in the above section that j should be less than equal to x. So maximum value of j can be x only. So 2 into 2 factorial, so until let's say 3 into 3 factorial. So at the end, the maximum remainder which we can get is of this form. So on is of this form. So until x into x minus 1 factorial, the maximum value of the remainder which we can get is of this form. This is the maximum remainder which we can get, and the minimum remainder which we can get is actually 0. So, and we know from the important observation which I had made, the third observation, that this value is always less than x factorial. So we have this section which is divisible by x factorial, and plus we have this section whose maximum value is equal to x factorial minus 1. So we can easily be able to say that this whole section can't be divisible by x factorial, can't be divisible by x factorial, can't be divisible by x factorial. So at the end we can conclude that if we will be able to convert all sections of 1 factorial into 2 factorial, let's say k sections of 1 factorial into k2 sections of 2 factorial, and then all the k2 sections of 2 factorial into 3 factorial, and so on, then the answer is yes. If at any point of step we won't be able to convert, then the answer is no. So let's move to the code section and we will see that how I have written the code. The code is very simple, the code is very short. First I had made a vector vi, then what I had done is I made a vector vk of size x plus 1. Then from I is equal to 0 till I is less than n, I am traversing vi. I am storing how many zeros are present, how many ones are present in the section in the form of vk of v of I plus plus. That is, suppose I want to know that how many values of 2 are present. So I will write what is the value of vk of 2. So it means that the vk of I represents that I factorial is present vk of I times. Now I have made a variable carry. First, initially the carry is 0. So what I have done is vk of I plus equal to carry. So vk of I is actually vk of I. Then I am trying to convert that vk of I. I know that the vk of I into I factorial, then I am trying to convert that vk of I into I plus what I'm doing is I'm actually dividing vk of I by I plus 1 and multiplying by I plus 1. That multiplied I plus 1 gets multiplied with I factorial. You can see here is that multiplied I can divide vk of I by I plus 1 and multiply by I plus 1. So that I plus 1 can combine with I factorial to give I plus 1 factorial. Now I have to check whether vk of I is divisible by I plus 1 or not. If vk of I is divisible by I plus 1, then we can say that the new carry, which will be carry forwarded, is vk of I by I plus 1. And if at any point of time we won't be able to convert whole value, then I increment no and then break. If no is greater than 0, then answer is no, else the answer is yes.